researchers in cloud computing. He's Redmond Barry distinguished professor at the University of Melbourne in Australia, and also the director of the Quantum Cloud Computing and Distributed Systems Group in the same university. And he also has he heads the startup that he founded, Manjula Soft, as you can see there on the screen, right? So Raj has he's got one of the highest number of publications in computer science, and definitely for cloud computing. And he's really nimble in terms of getting into newer areas, and sometimes he goes and does some of the early works in pioneering areas, and that always sort of makes it easier for a bunch of others who sort of follow on in his footsteps. And the two things that I sort of always remember Raj for, besides his research accomplishments, service and spirituality. I'm sure you'll see this in his talk today as well. So he's been the founding, everything from the founding editor-in-chief for IEEE Transaction and Cloud Computing to starting off a bunch of conferences such as CC Grid and many others. And ICSP, these are two ones that I'm associated with, besides many others. And he also makes sure that it's a very democratized conference. It goes all over the world, and not just stay in Western countries. So that's definitely something that, and he's conscious about that. And the other spirituality, which I'm sure that he will see him infuse into his talks as well, right? So with that, Raj, over to you.
Thank you. Good afternoon, almost evening, good evening. Thank you, I guess, for inviting me to visit IAC. It is always a pleasure and a privilege to be here. And of course, this computational science with SCRC earlier, this Master of Computational Science. So my connection dates back to Professor Balki. So he said, Raj, we're starting computational science master program. And then I want to introduce this high performance cloud computing. So even before that, I connected with before you guys joined. Of course, Lakshmi has been around for a long time, correct? So thank you. So as you guys mentioned, I'm going to talk about briefly some of the latest development in cloud computing, so and also quantum. So cloud becomes a foundation through which we can deliver quantum. So we will discuss both of them together in integrated fashion. So that is the topic, and of course these are very hot topics too, also from the perspective of market. So in the market you see AI is very popular, may not be in terms of creating fundamental models of AI, but applying AI for solving real world problems, and that is clearly reflected in having department name itself is CDC. I was thinking, so maybe it can be better named as some AI, School of AI, Department of AI. That's what people in other countries have done. In, for example, I was there in China for 3 weeks. Many major universities, they just renamed all their schools into School of AI, and seems to be doing quite a bit of those work.
One is a virtual center.
Yes.
To make it into a school.
Yeah. Through there, they talk about AI chip, AI platform, AI OS, AI application. So everything AI, from real computing science to artificial computing science. Yeah. So outline just briefly. This is something most of you know. So in one slide, I will say how computing paradigms have evolved. Then, of course, we will take a look at more into the cloud very briefly. So then we discuss this cloud architecture, this ability to scale it in a seamless manner. So very briefly. So then I will discuss about Aneka platform. So of course, Aneka platform has been around, but I like to mention about the latest version of Aneka, which is Aneka 6, what we have for supporting application. So then this quantum computing everywhere, at least from the perspective of attracting some funding. Correct. All the academics are thinking about quantum as a source of money, income. So income is important too. So we have to think about it. So the quantum computing. So we have one program we call iQuantum, and of course these days everything has to be I. Correct. Whatever you do, attach I before it if you can't find a new term for yourself. So that's the easiest way. iQuantum initiative in Melbourne. So I will give you some foundation concept in case you are not aware. So then briefly touch on what we do in Melbourne. 2 of our efforts I will discuss. Then conclude at the end. So moving forward, the first one. So there are different waves in computing, different waves in communication. So these days we have got waves and waves. Correct. If you don't have any another waves, you might find waves in the city. When there is a heavy rain, you will see waves. In Bangalore in particular, if you go to some of this area where there is a higher slope and down and huge amount of water, and if you are just on a bike, will be, if you don't know sinking, only God knows what your future will be. You should know swimming, very important. So in this kind of traffic, if you somehow fall into water, and 2 days ago there was huge rain, so make sure that you learn swimming as well. So otherwise you will become just a pandita, expert without knowing swimming. So real life will be very difficult. So okay, so different computing paradigms, and of course our focus will be on that cloud and IoT. So these are the latest development. So building on creating virtualized systems, so that this way we can deploy applications on virtualized compute systems. The compute system during night time we have a less load, that time we consolidate, when there is a heavy load we expand. So that is the concept with this virtualization came into picture, but this was a nice model for delivering computing as a utility. Okay, that is what cloud is doing it. So then quantum is, of course, in computing we keep inventing new things. So before solving our current problem, so quantum is one new one that is coming up in the hardware level, lot of focus right now, developing quantum chips, so which are of course starting with all noisy. So the noisy presents an opportunity for people like us. How can we build a reliable computing services on top of noisy hardware? Okay. So whenever there is a noise, that's an opportunity, correct? Every problem is opportunity for researchers. Yeah. So I will touch on those things. Of course, in between IoT, Internet of Things. These days looks like IoT is happening in a big way in many places. Even this place like, for example, PS University, IoT lab, massive number of drones, massive number of robots, and in smart manufacturing, and then asking people to program runs on a edge, program runs on a cloud. So that is what this edge and IoT seems integrated, but earlier such things were happening in the cloud. Okay. So we will focus on those three things, and then all these drivers in the past, the requirement for these technology advances in the past came from scientific application, military application, of course business, but now they are driven by population oriented application. So whatever we do, let it to be accessible to everyone, common people, whether village or city or in between, wherever. So should be available. So that is the focus. So therefore all these clouds are the technology that are uniquely created for all mass population oriented application. Like CRC has been around, but who were the users? Most the big scientific people only, correct? So whereas when you bring it to cloud, everyone on the street are using it. So if you happen to use a WhatsApp, you are a cloud directed communication system, or if you use Zoom, cloud hosted application. So how does cloud look like? Those who are a bit beginning. So simply, so we have compute services, application services, storage services, all somewhere in the network, and they are presented to end users by a company which we call cloud service provider. Okay, you as a consumer simply subscribe to the service and use it and pay for what you consume. So this is pretty simple looks like, and you may have subscribed to one of the service provider. Let's call this as a service provider A. Then actually this service provider A doesn't do everything for you. So when you go at the underlying system, so they end up having distributed physically, geographically distributed environment. So maybe countrywide cloud or a international cloud. So application running there. So the users make a request. Then obviously those are composite services put together and deliver that as service. So that is how this cloud system are architected. And if you look at many applications, they are in this nature. And even simple, and these are applications are available as service. In fact, last 1 month I was in China, and when you are in China, they will not know English and I don't know Chinese. But we need to communicate, to do business, whatever you want. So then I also went to a conference, CCF Services 2025. So there they had 1,500 participants. And then all this, some of the keynote speakers, not many except me, all of them are presenting very nicely in Chinese. So what about me? I am sitting there, how do I hear? So then I quickly downloaded an app. So this app, so it translates from English, Chinese to English or English to Chinese. Quite reasonably good enough. Even in conference, somebody speaking far away, it comes. Then initially it gave me, free for 1 hour and around, just certain limit. Then after it is asking me to pay. If you don't pay, it stops working. So therefore, initially some service may be available to you freely. Then obviously later on you have to pay for it. And this translation, live translation from the voice to the text to the English is coming, real time. Quite real time. So I could make up what they are talking. And this is very common also. You go to some place, even a check-in counter, they will do. So you start speaking whatever language you want. So they will hold near your mouth and they get. Then vice versa, they say something to do, then show it to you. So the live translation. See, you can see these applications are now coming to the masses everywhere. So that is in simple term, and these are cloud mediated, cloud hosted application services. And there are many of those. This is the layered architecture of cloud. Then if you are someone in the beginning in the cloud computing, say 2011, 12, 14, at that time you only had 3 layered architecture. You open up a textbook or even papers, you will see 3 layers. Correct? I am sure your paper also would have 3 layers. Even my paper also had 3 layers. Lakshmi paper had 3 layers. So those layers are infrastructure service. Then this the application services. Then of course platform service. Now as we advance, people wanted to make this programming simpler. So therefore application programming simpler. So that came into picture what we call function as a service. Okay. So you simply write an application made up of functions. Don't worry about where to deploy them, or when to deploy them, how long to deploy them, how much memory you should allocate, how much compute you should allocate. All that don't worry. So you create and run. And then you only pay for if your function runs. Whereas earlier, during this model of infrastructure, whether your function runs or not runs, your virtual machine is created, you have to pay for it. Okay. So there is a change in terms of cost optimization, change in terms of efficient way of creating application, and then the deployment. So that is that layer. Then of course in between we have got storage services such as, for example, Dropbox. All of us use it. Then coming to application, all kinds of applications that used to be on laptop, now they move to cloud. Yogesh and I, we wanted to put together one fellowship application. Quickly, where do we put? So, if he edit a document and email me and hear it and email to me, then, it won't be synced properly, and then we suddenly morning get up, we have so many emails, which one is the latest version can be confusing. And emails also, just because you wrote email first, that means that it will come to me first. Correct? We know this problem. Timing problem, time ordering problem, distributed system. So that can be solved with this storage clouds. So very good. And of course applications through online like this, all this. Then not only this business application, of course all our scientific people, instead of running their application on supercomputers, they found, oh, why don't we run it on the cloud? In fact, during the lockdown time, so we got one big money to build a GPU based data center. Then the moment lockdown in this COVID came, then everybody said, no, we don't want to contribute that much money. The universities which promised earlier, they didn't do. Then who will also getting machines also problem. No one shipping from other places. So we have to just gain access to the cloud, then start using it. So scientific application in the cloud, then obviously all these things like Zoom. Then of course nowadays everybody talks about LLMs and LLM based system like ChatGPT. In China they talk about DeepSeek and so many of those. So these applications, they are cloud powered. So you can see cloud is here, everyone is using. Correct? Who all are using? Lawyers are using Law GPT. And if you are someone want to write a poem but don't know how to express it, correct? You use Poem GPT. Poem GPT, just say, so I am standing at this place, very nice mountain, greenery around the water, then I am missing you, just say 4 points, then ask you to write a poem. So I was thinking, let me try it out. I never wrote a poem. So I put, then yes, do you want to make personalized? Yes, tell me what is your wife's name. So give a name. Then you will write nice poem also. Yeah, so like this, people are using this our technology for all sorts of things. So that is a success. Anyone who works on cloud computing must feel that I think we helped impact in a great way. Okay. So now, how all this concept evolved? So this is just in briefly. So all the people who did research during 2008 or up to 10, they were all writing or working on how to provision virtual machine, how to manage the life cycle, how to get the performance best out of it. This kind of research that is virtual machine based. And if you're looking for doing experimental computer science research, you would use some technology like this. This is an example. There were many others. Then as we move forward, then came this container concept. Oh, installing this application is too complex, so we want to simplify, then I can deploy it very easily wherever I want. So that container came into picture. So this container based research. Then move forward, then as I said, this IoT is became gaining popularity. So before that, before this something like 2015, we used to do this IoT smart city application on the cloud environment. then the popularity number of users increase. Therefore, they are feeling response time little slow. Oh, why don't we also have a either roadside units as a compute at the edge capability. So that edge come into picture. So we also did research in this area. We developed something called Fogbus software, open source system. Then of course this software defined network, SDN network community explored a little bit. But of course people want to apply that for also cloud data center, make them as a software defined data centers. So this way not only compute virtualization, now we have network virtualization. Now you have got compute and network virtualization, then you think about how do I manage the capability. So maybe not only efficient use of compute resource, but I also want to use network resources efficiently. Then I also may want to make sure that my application deliver the best performance by having suitable co-location. So that kind of research. Then of course serverless I mentioned, which is function as a service, and now quantum as a service. Okay, so we will discuss about quantum part as we go along, and this is on the technology side. Then the researchers, like even Yogesh when he was in US, so you may not have access to this big facility if you want to experiment with. Even if you have a big money, but they won't give it to you maximum maybe 200 virtual machine if you are lucky. Otherwise, most people get only few. Okay, so therefore, what do? You do go for modeling and simulation. So in that space, similar concept development. So we were always into creating also some kind of simulator that helps us, but also help the community. So this was the cloud sim. So we created in 2008 and then released as newer capability came into picture. So we also added those capability to that simulator. So for example, container concept to cloud sim, then edge and the fog concept to IoT modeling. Then creating edge and fog concepts, then SDN came, SDN concept, then of course serverless came, serverless concept. Now quantum came. We thought of course we want to move again all the research towards quantum. So then we created something called iQuantum simulator. So the simulation system. So this simulation system of course not just used by academics like us, even the companies like IBM use it. Why? So if you go back to 2008, IBM or Microsoft or Google, they were not in cloud business, but now they are in cloud business. Of course, otherwise they would have disappeared. So if Microsoft had not moved to cloud, it would have been a history. It would have been history in history book. But good that they changed the CEO. Then this Satya came into picture, and he quickly changed the whole thing to a cloud-oriented company. So you can see, so many of these companies like IBM or HP, Ericsson for that matter. So they wanted to do what we call mobile cloud services. And before you build a big facility, big plan, so you first someone model and showcase what is the level of capability to build and what are the application, how you should be architecting, how this will be interacting and work together. For that purpose, this Ericsson use this cloud sim for that also. So if you just search cloud sim, Stanford, you will hit a PowerPoint presentation slides of CTO of Ericsson presented at Stanford University. So that talks about how cloud sim is used. So many of these companies have used. Of course, universities all over the world, correct, have used cloud sim. Then in terms of paper, right now more than 6,700 research papers are published, and all of them use cloud sim for evaluating their ideas. Performance evaluation section. Usually say I use such a data set, and cloud sim to model the infrastructure and model the application. Then I develop my own policy, and here is my demonstration of how good it is. Okay, and here may be performance improvement, cost improvement, energy improvement, whatever improvement. So this cloud sim played a role. So that is an example of how you can also build. Suppose in your master's work or bachelor work, if you happen to develop some kind of approach and the tool set for evaluating your idea, most of the time you write a paper and you forget about it. But if you put some extra effort to turn that underlying system into a small package, then separate your logic and your that evaluation approach as a separate, then you can release them separately. So then of course if you continue to maintain it, so you will have lots of users. So this is an example of how to make some of your research successful, correct. So cloud sim was not our main research. Our research was a cloud computing. We just happened to create something for our use. Then we found, of course, let us separate it out. So we did like this for grid computing time also. Satish was in grid computing person, correct? That's how I know him. So at that time, similarly for cloud, and of course similarly for fog and edge computing, and we are doing similarly for quantum as well. Okay. Now, what are the new things apart from all of these that already happened? So one, for those who are interested in software engineering, so this microservice based software engineering is one hot area. So people are doing manually transforming application into a microservice application, but those interested in software engineering, you can think of creating tools that can analyze all this code, let's say Java code, and identify classes, the relationship, and clustering of those classes. Then of course here are the 20 groups in my application, create them into transform them into 20 microservices that can be deployed. There can be multiple replicas. If one of the service fails, we can move it to other place. This way we can offer reliable services. Doing manually is one, then doing automated way is another way. So this automated is something needed in software engineering. Those who are interested in software engineering, think of how to transform legacy application into microservice base, and how can I create a tool that does all of the work. Then coming to of course blockchain, we know a lot about it, but blockchain can also be used for creating trustable services. Given that so many ubiquitous services, whether the healthcare application, let us say, or financial application as a service, so these you want to be trustable services. So you can do that by embedding blockchain into right from the data acquisition to data transmission, then processing, and the results can come back all the way. You can make sure that nobody has broken the chain. If they broken, at least we can say it is not trustable. Then moving forward, of course, these days LLM is very popular. But we want to use LLM for better software engineering. We want to use LLM for better system management. Even our cloud system become very complex. Managing them by creating some deep learning DRL based method for resource management, blah blah blah, is too hard to code. So we can use the help of LLM. So later I will show you an example of how simple it is. No coding, but you can write a very nice scheduling algorithm. Correct? I'm sure Satish can tell you, he did done, I still remember, scheduling of this distributed system. So we had to spend our 3-4 years of PhD time in creating some tool algorithm and evaluating it. But with LLM, if you are very smart, you take one piece of a paper, write that script and give it, and evening you have a paper ready. Correct? Algorithm, you don't have to write a code, so it will evaluate, compare it to 2 other algorithms that are there. Then of course it will generate a graph, and also it will write a paper for you. Correct? So that is your script. Then here is the implementation, and here is the comparison. So within 3 hours, without need of PhD student, without need of programmers and assistant, no need of RS. So it's a self-assistant, self-created. So I will discuss about this LLM based. This is I think very new at this moment. So not many papers are there. Just many people are trying to explore the use of LLM in system engineering and software engineering and so on. So this market-oriented, just conceptual. This slide I have been presenting it for quite some time, but I want to highlight that of course we have got several physical machines obviously there, and these are virtualized, and then computer virtualized, network virtualized. Then here are the users at the top, and they come to the system, and then as far as service at the quality. So I gave an example of that Chinese live translation of voice to the text, or voice to English to Chinese to English, or English to voice. So this requires a real-time capability. So when the request comes in, so sometimes you can specify the service quality. They might say, I don't mind tolerating 1 minute delay. So let speaker speak, but you give me the translated version in 1 minute. So I may not be live seeing what he's talking, but it's okay, something better than dumb. But if you want real time, so then of course we need to have a better service provisioning. So that initially that service quality, admission control, if you agree to provide the service, you come here and start running on some couple of virtual machines which are provisioned, then which are mapped to this physical machine, then services offered. Of course, even the research on how to map these VMs to PM efficiently in terms of performance, in terms of energy efficiency is another piece of research to explore. And also it depends on application structure. If you have to build an application having 5 different tasks, and if they are independent oriented, no problem. But if they are frequently communicating among themselves, how do you place them? If you simply place those VMs just randomly, this one here, what happens? If they are communicating too often, so performance will be down. Just like if 2 of you always want to chit chat in the class. Correct? If you sit next to each other, you can do something, you can communicate. But if one is at that corner, other this corner, so there is a latency loss, plus it is a noise for the people who are in between, correct? So then you will be slow, you are not able to communicate effectively. Same thing happens. So here also how to map based on application structure. Then of course, when the load on the application is very high as time progresses, what do? You dynamically provision extra resource, which can be from one location or multiple location, which can depends on where these users are coming from. If users are coming from Bangalore, okay, data center from Bangalore. If users are coming from Chennai or Delhi or Mumbai, then you distribute those accordingly, so that all of them can get the best response time from wherever they are. So this is called multi-cloud computing, physically distributed, geographically distributed. Then of course, when the demand decreases, you reduce it. So this is a conceptual level of what we call elastic computing. Okay, so this elastic computing. So just to give an example, so this is like. I am sure you all heard about Hanuman Chalis, correct? So number 9, this is Sukshma Rupa Dhari Siyai Dekavo, Vikata Rupa Dhari Lanka Jalavo. So who is doing this? Glorifying Hanuman, correct? Hanuman Chalis. So Hanuman. So Hanuman can become smaller than smallest, bigger than biggest. When he wanted to present himself in front of Sita, so he didn't want to scare her. So he became like a small baby monkey, Sukshma Rupa, and presented and conveyed. So that is how he behaved. Then when he went in front of Ravana, so there no Sukshma Rupa, Vikata Rupa. So Vikata Rupa Dhari Lanka Jalavo. So how did he burn it? So when he sat in front, Hanuman was not presented with any chair. So therefore he was a self-sufficient person. He made a chair himself by through tail and sat on it. And that chair happens to be higher than Ravana. Ravana was not happy. We should have given him one chair. Created a headache for us. So much ego heart. So then after that, so he conveyed a message of Rama. Then he, of course, he didn't accept it, rejected. They said, let us teach a lesson to this monkey. So they put a fire to the Hanuman tail. What did Hanuman do? If it is the people of today, what do? They pick up their mobile phone, take one selfie photo, put it on Facebook, then we'll see what happens. Correct? House on a fire, they are not doing house on a fire. First take a photo, put it on Facebook. Then after that, call 000 from fire agency. But Hanuman became, he became bigger and bigger. He put, first foot on number 10 building. Then after that, number 50. Like this, he burned the whole Lanka. So this is like expanding and shrinking seamlessly. Then if you are building services, so let's say you are building services on this, some of those are building services, and they also have to exhibit this quality of ability to expand and shrink as necessary, scale out or scale in, or scale up, or scale down, whatever, dynamically. And if you do that, what is the benefit? Resource efficiency will achieve, cost efficiency will achieve, energy efficiency will also achieve. So for information, right now there are more than 10 million data centers worldwide supporting cloud services, and these are like a Kumbhakarna. They consume so much of energy. Some of the studies are showing that earlier. So their engineering consumption is almost like some combined energy consumption of all those 10 million data centers is more than country like India. At least some few smaller countries like like Netherlands and few other. So much of energy they are consuming. Now with our ubiquitous move towards using this cloud for all sorts of things, so by 2030 they are saying it will double. From today, 2025, how much are they consuming? The same data centers with the expanded applications and the ubiquitous in nature, in 2030 it will double. So massive amount of energy consumed. Then the biggest culprit these days are these LLMs. Everyone creating LLM for all these nonsense things also. And they are making movie also. If you don't know how to make movie, very easy these days. Just write a storyline. Say, I want such a character, then you make a nice movie also. We don't need any film star, hero or heroine. All made with this. All need is creativity. What message you want to convey. So that is the issue. Now we need to be able to build applications that exhibit in nature. How do we do it? So one of them, we need a right platform for building application. Let me introduce briefly this. Aneka is a cloud application platform that has got two key components, SDK, software development kit, having different models of programming such as thread, task, map reduce, message passing, and many others. Just for example, these three are more prominent one. I highlight. So you build this application, then you can deploy either in a private network cloud, or you can deploy in public cloud or multi-cloud. Okay. And we say, oh, this is the world first platform supporting multiple models of programming. So we say world first platform. So it was created first time in 2008, we released. At that time no one had it. And how did we make it possible? Multiple models programming. So we have this container, this container, now container became popular, but earlier we had a service oriented container we created within CloudSIEM, and this container was hosting fundamental services. So managing Fabric, managing all these common services, and by extending the services you can implement whatever model programming you like. Thread, task, MapReduce, many of our colleagues in USA, they have created data flow model programming and some Scala level programming, obviously of course MPI like programming, lots of different model programming. And tomorrow if you have got idea for a new model programming, you don't have to create all of this yourself. Simply take and extend and implement new model programming, rest of it is already there. Okay, so that is our innovation. Then, so let us say for a given model you need a scheduler. There is a default scheduler. So you want to take it out and put a new one. So you can do that. So plus also, so when you deploy on the system, let's say you have application just simply uses MapReduce, nothing else. Why should we load all other unnecessary burden? Correct? So you just keep what is needed. So it is a dynamically reconfigurable system. So that is our architecture. We received US patent in 2012. But the invention dates back to 2007. That was Australian patent. After that, we also filed for Indian patent. Then in 2 years ago, already 2012 minus like 2025 is already almost 13 years over, because the life of patent is only 20 years in USA. You should make something out of it. And meanwhile, many commercial companies have similar approach to building. Then so that we found this an opportunity. So as a result, 2 years ago, we were able to license this patent invention approach to so many IT companies you can think of: IBM, Microsoft, Google, Salesforce, blah blah whatever. So many of them. Okay, so this is another way. If you create something unique and if you happen to make a patent, then of course that is something should be very unique that many commercial people follow it. Then only you can enforce your invention. Correct? So like for example, in Australia invented Wi-Fi. Correct? Everybody is Wi-Fi, but nobody was paying anything to Australia. For some of take many companies to the court, finally they give $500 million. So that was the Australian invention. So, but we didn't get 500 million, so very little, some few millions only. Okay, so I didn't follow their approach because they had to appoint a court lawyer, spend 25 million to sue them, whereas I don't want to spend anything. Correct? So during COVID term, who was interested? 2021, people were just happy if they can survive. Correct? Most people were just happy if I will survive. I don't care about money. So we just said, okay, anybody interested, and gave it. Looks like fortunately that was a good time to also license during lockdown period. Okay, so that was another one. And this software, as I told you, it is evolved for all this period, and the latest version now is this Aneka 6, primarily also supporting this AI, means deep learning, machine learning, IoT, all those applications. Because if you want to sell in the marketplace, you have to have the latest offering so that you can continue to sell. So this Aneka, so let us say we provision a couple of servers and I want to program, and programming made easier. Say for example, this is a task. Let's say this is a task for performing data computing one camera. So here we have got one camera, so there another camera. Like this, there are so many cameras throughout the campus and throughout Bengaluru city also. Now I want to see, is this campus safe? Correct? So how do I find out? Maybe I can process from one camera, but there are n number of cameras. I want entire camera to be safe, entire campus to be safe. If I want to leave the this building and want to go home outside, like Lakshmi in the Malleshwaram, correct? Where Malleshwaram? I didn't go to Haram, but I know that she is in Malleshwaram. Anyway, Malleshwaram, so whole campus has to be safety, not just this building. So for that purpose, you have, say for example, 1,000 cameras. So 0 to n-1, the n number of cameras. Then you create a task, that's it. So the Aneka will take care of provisioning suitable resources, take care of this scalability, take care of failures, take care of the cost of every computation and so on. So the programming made easier. And in terms of deployment, let's say I got this image, then I can split this into into multiple segments, 3 rows, 3 column, 9 segments, 9 work units, and I make them as Aneka, say for example thread. Then the system will provision resource, move these work units and process there. And after processing, so results come back. Then of course I present result to the application. In this case, I applied filter called emboss. So this image now turns into emboss. So, and meanwhile, whatever resource we needed, they are released, correct. So, acquire, use and release. So, the user do not have to do that, system will do it for you, but this is a conceptual way of doing it, and this depends upon type of filter you applied. In this case, I applied emboss. The image initially looked like a 2D, now this looks like a 3D, just suitable for putting it on a Indian coin in the future, if still coins, physical coins are there, correct. Now we talk about the digital coin. I don't know whether they will be there, but anyway, this is something available in case necessary. So, this technology used by many people around the world, apart from education. So, China Railways Corporation, of course, in China they have really high speed trains. I will tell about that. Then Indian Space, ISRO here. So, satellite image processing. So, they have done quite a bit of interesting application. So, satellite data, bring it to receiving station, the local, and then process it for example, disaster detection and management. One such application was done by ISRO. Then Washington State University. So, if you consider medical data analytics, so of course, there are privacy constraints are there. So, they built a deep learning classifier that classifies medical records into sensitive and non-sensitive. Then sensitive ones are processed on a Washington Hospital cloud, non-sensitive done on a public cloud like Amazon. Then how to do this? And then they use our Aneka to plug in their idea and demonstrate. You search, they have a very nice thesis explaining this. So, then of course, this deep learning and so on. So, just to show you two applications, the first one from this China Railways Corporation, these are different design scenarios, and you do rendering using software called Maya on server like this, find out which is the best design for me. So, in China really they got, I was talking to Yogesh. So, within 3 weeks I went to 10 cities. From one city to other city, if I take aeroplane, it will take 2.5 hours, and at the same time in train also. Correct. Actually, airplane will take more time because you have to go 2 hours in advance to the airport. Airport is very far away from the city. Then, if you are lucky, the flight will go on time. Then it lands successfully, let us say properly. Otherwise, like it can happen like a Gujarat, very in danger. So then, correct. Gujarat, you heard? People forget very quickly. Correct. It was like in big news. Now nobody talks about it. Not even government. I think everybody forgot, including their so-called loved ones also. This is how the nature of material world is. Correct. Quickly they will forget. The time is like that. So anyway, so that takes some time, but with these trains from city to city very quickly, very comfortable and low cost also. So this China Railways Corporation is responsible for that, and they in 2009, so they built a small scale cloud-like environment inside the organization, and we have a tool called Design Explorer. This support what we call SPMD, single program multiple data model. It's very easy. So single program is Maya, multiple data all this scenario. I run it, and by running, so what took something like single server 80 hours, and they did it in 2 hours, and 2 hours also sometime very late. For example, if Modi is visiting some mechanical engineering department in Institute of Science, if you ask him for wait for a 2 year to show some new design for new Vande Bharat, he can't wait. But if you say 10 minutes, no problem, correct? So he will say 10 minutes, sir, have a chai for 5 minutes, then we'll be ready with the answer. So therefore, what do we do? So we can say here keyword setting deadline D equal to 10 minutes. You can set a time now plus 10 minutes. Okay, the 10 minutes. Then local resource takes, let's say SCRC will take 2 hours, but I want answer in 10 minutes. What do I do? So I can rent extra resource from some other cloud services that are available. So therefore, we can set a budget. Correct? Budget is also important. We don't have infinite money. Nobody has infinite money for that matter. Even the country doesn't have infinite money. Even America doesn't have infinite money. That's why they are putting tariff. Correct? Another way to collect money from other Indians, other people. Correct? In India also we don't have. That's why we got a finance minister to manage the budget. So we should set a budget limit. Budget is equal to, say for example, 500 rupees. Correct? RS 500 rupees. So given a deadline and a budget of 500 rupees, the system on your behalf looks into marketplace, how much I need, how much I got, what is the requirement, then rent those capabilities together, manage the execution within the deadline of 10 minutes and budget of 500 rupees. Of course, if it is not possible, they will say inflexible request, increase the budget or relax the deadline, something you have to do. Okay, so this is the deadline, budget aware scheduling, resource management and provisioning on the cloud. Okay, you just whatever I say the keyword, you put it into Google, it will give answer. If it is not giving answer, don't trust it anymore. Yeah. So that is one. So like this, we did healthcare application. Also, healthcare is another important connected to everyone. So we have this body area sensor networks. Of course, these days many people have got what do they call smartwatches. smart watches, and nobody want to have this kind of standard watches. They want smart watches, especially young people. So smart watches, you collect the data from here with the mobile phone, an app sending the request to a service like ECG as a service, running on an ecosystem on some kind of cloud. Of course, here also QoS is very important. The people in emergency, they want answer very quickly. Someone in emergency, they want answer within 2 minutes. Others who are relaxed, they want answer in a 24 hour. So like this, lots of requests are coming in, how to manage and provision and deliver as per the QoS requirement of users. So this is the system. So we have shown various versions of this. This is the first version. So data collection. So this person, our, what is his name? Shantanu. So it's a real person, still exists in near Princeton, where Rensselaer, no. Yeah, Manish used to work the place, no? Yeah. So the data collection, so send it to mobile phone, send it to somewhere in the cloud, then process and results come back. So this is a, you can create many interesting application from here, going there and send it somewhere in the cloud, process, and we have got this result. Now, so depending upon scenario, you can do a lot of things out of this result. For example, you can use it for admission control. If someone is entering into the door, in fact, somebody is coming. Okay, so our person only, he came earlier. And if somebody is new, then for a second find out how many hours he has slept yesterday night, the night time. If he has slept more than 5 hours, welcome. Suppose if they manage to sleep 1 or 2 hours, such people, what happens? They come straight and sit in front and air conditioned room. In no time they fall asleep. Correct? Especially during seminars, very easy to sleep in the classroom and seminar. Yeah, in the 21st century, actually sleeping is a luxury. Even though you got 5-star bed and 5-star pillow created using pillow science. You heard about pillow science? There is science for pillow also. You see, not just for science for instrument, but science for pillow. So even then, sleeping is very difficult. So here, so you can find out if they have slept more than less than 2 hours. For such people, you can give them, and have some tea and drink nicely, and then freshen up a little bit, and go there and wash your face and come and sit down. So admission control management can be very useful here. So like this, you can create lots of healthcare application. Even simple thing like depend upon your body condition, so your disease condition. These days everybody is disease. Maybe if you have got say diabetes. So what is the best food to eat in this place? In Bangalore. If I go to Hassan, what is the best food to eat? Like ragi mudde, you heard about? If you eat ragi mudde there and come back, you will be healthy. Instead of eating the food available here. So depend upon place, depend upon our condition. The system knows us, system knows the where you are, system knows what is the nearest place to eat. So we can, like this application apps you can create. So next, deep learning. So deep learning is important, correct? We want to learn deeply, then only we become wise people. So this is a deep learning. So deep learning can be used for many purposes, including detecting objects in the images and videos and so on. So these are the different cameras, data coming in. So there are various deep learning programs like ULO.py, Deep.py, various programs are there. They are designed to run on a server. But we now want to use multiple of those in the cloud. So we cloud enabled, that means apply our task model programming, transform this into sort of a cloud native scalable application. So when the data comes from lots of cameras, so we can process across the local resource or across multiple different cloud resources. So in this case, for example, when we feed so this image, here it is able to identify all the objects, including things such as keyboard, mouse, chair, people, and then it also depends quality. If you want high accuracy, more detailed detection, low accuracy but quick answer, maybe the coarse grain detection. So this can be used for various purposes, including, for example, this camera, take one snap, find out who all are in the classroom. No need to take a manual attendance. One problem solved. Then second, how many people are feeling drowsy? Or how many people are sleeping, how many people are happy? This can be good input for the speaker. Maybe let's tell some jokes, awake them, most of them, correct? Or some places they serve a tea. Then we can serve a targeted tea serving. Those who are sleeping, give them give others who are happy, no disturb them, correct? So such application. And of course, if you are in some places, I was in that Belgaum, so there that VTU University is in the forest. And there you will see sometime tigers moving around. Tigers, of course, from the window, snakes also come. So we need to have all this detection so that to see when to go out of the office. correct? You don't want a hungry tiger standing in front of your office or in front of SRC building. So these are real. So we should have all these kind of things that help us to manage our life safely. So this is the deep learning. The next is machine learning and NLP together. So during this year 2020, 21, 22, people who were too much productive, especially researchers. So they end up writing more than 500,000 papers. Some papers having COVID in the title or in the abstract or inside the body of it. Okay, everyone, whether you are a mechanical guy, automobile guy, for the first time in my life, I went to that bathroom. Here they call it restroom. I don't know why they call restroom. You rest there and come here. So there you want to wash your hand. So I was there is no knob to get the water. I put there. It's not working also smartly for the water. But thinking, what do I do? Then something press and get the water. He said this is the invention for COVID. So like that, everybody somehow they did their design for the purpose. So there is a data set called COVID Open Research Dataset 19 Challenge. So this has all the papers that you can think of related to COVID. So massive amount of data. We took the data, processed it, passed it, then created a machine learning based training using our Aneka. Then of course post-processed data available. So what for? If you want to find out what is the best vaccine for any variant of COVID, going through all those 500,000 papers, who has the time? Nobody has time. You ask Google, Google will only give you some big listing, right? But I want a refined answer. Okay, for example, a paper co-authored by Melbourne Medical School and AIMS, Bangalore, let's say, we put, and for this variant. This will give me only top 2 paper related to it. So if I search using one server, it will take me 2 hours. But I want answer in maybe 1 minute, very quick, right? So it's a life and death problem. So in the COVID time. So here we are showing if you have got 50,000 papers, this much time it took. So instead, if you want quickly answer, maybe we provision 5 or 10 or 15 based on your keywords, it gives the answer. So because we also want to do something in COVID at that time, helping in some way within our capacity. So this is one we implemented in that Aneka. Okay, this is the software from Andhrasoft. You can download, and the latest version, as I said, Aneka 6. And so this technology, not only those industrial users, but also many universities throughout India, in China, in America, in Europe, they are using it, and they have set up a cloud lab for the teaching purpose. So here all the way from say this Kanyakumari to Kashmir, from Maharashtra, that Maharashtra is famous, Kolhapur. Kolhapur is not only famous for Kolhapur chappals, correct? I think there is somebody suing company, I don't know what, some company, branded company, they are selling Kolhapur one, so people are suing them. So anyway, there Kolhapur, there also Mahalakshmi. So Mahalakshmi too, so Meghalaya, lot of water there. So Maharashtra, not much water, the dry place, but you go to Meghalaya, lot of water. So place, no water place to water place. Then Kanyakumari to Kashmir. So we have this deployment everywhere. They are teaching cloud computing subject in universities as well. So now coming to quantum. Quantum is a big thing, of course. Everyone is talking, including Modi also. Of course, Modi thought, okay, I want to make India great again, like Trump. So they created a national quantum mission, then invested a lot of money. I believe that IIC is also leading one of that 4 or 5 areas in this one. Then looking into many things, including communication. People are now want quantum internet. So if I want to transfer, Yogesh was telling me, the data set from one of that place, they went there and took the hard devices and copied and brought here. It took some of the time. If you were to do today's internet, it would have taken 1 year. So maybe once we have got a quantum internet, we can get it in 1 second. Then we don't have to send several students and carrying bags with storage devices. So we need to have a better quantum communication. So this is one of the area of research. Then of course, if you want to know just quick difference between this classical and quantum, just in a one slide. So we know that already this digital computing, so representation of state or calculation with transistor just either 0 or 1. Then we program like this at the low level. So that is in brief. Then coming to quantum. So in quantum, so at the same time that quantum particle can be state can be either 1 and 0 at the same time. That means a particle can be physically more than one place simultaneously. You got it? For example, so I am just here means I am here only. in this building. I am not in administrative building. I am not in Hare Krishna temple. I am not in Melbourne. I am just here. But if I were to have a quantum property, at the same time I can be in multiple places at the same time, just like Lord Krishna. You know, in Rasa dance, how many gopis were there? Thousands of those. So in the dance, he was able to be, he was able, you know, because of his ability, that superposition capability. So he was with each and every gopi and dancing. That is called superposition. You got it? Not only dancing with gopis, that is called Parake Rasa. In the Sokya Rasa, you know, when he married 16,108 palaces were there. And he was there in each and every palace. Correct? Ask Narada Muni, he will tell you. I don't know. That's what Narada Muni said. So that is called superposition property. Same thing here. If you have got, say, for example, 2 raised to 20 qubits computer. So 20 qubits. So 20 into that 2 raised to 20, it become 1 million states. Then we are saying, okay, 1 million these states, and each of these quantum can perform some operation for us. So let us say I want to break a key. Correct? So I got, say, 2048 byte key, and I want to break it. If I use the supercomputer from here, CRC, it will take 1 billion year. By that 1 billion year, I don't know who will be the director. Correct? Right now, Satish sir, right? Who is the director of CRC? Okay. Yeah. But in 1 billion year, we don't know who will be. Correct? So that is not feasible. But people say, if I have such a quantum computer with 1000 qubits, I can break it in 5 seconds. Okay, so that is also danger. But anyway, so you can use it for better things such as modeling, simulation, drug discovery, investment risk analysis, and so on. Okay, then I hope this is clear. Superposition. Then this entanglement is another concept. So entanglement is something like in say in the Kurukshetra war, you know, this Sanjay is explaining what is happening in that place in the war to Dhritarashtra. So they were entangled. So whatever is happening there, it is also happening here. So now in terms of programming, if you want to program this, so for example, you got a 4 qubits system, you encode the data, write a circuitry, and after the results come, you measure it. So here inside you got, there are 250 or more than 250 gates are there. So based on your application type, you arrange gates on different bits, and that does the processing. Then at some point you want to entangle them, for example, this to this. So you have, this is how you program. So that is quantum computing. So of course you can access quantum computer today. So right now through cloud, so through some special arrangement. Then if you don't have money, you make a friendship with some university people having quantum computer. So this is one, they claim themselves as the world first university having a quantum computer, Rensselaer Polytechnic Institute. So I was there in October. So another way of accessing. So therefore somehow or other, use your money or a friendship or a power, whatever, you can gain access to it. If that doesn't work, don't worry, we have a simulator for you. So okay, so circuit programming, I already told you, very complex. This is 2 low level, say 10 qubits. This is the task for random number generation, the different gates, and on top of it, once you want to run it on a real hardware, so this circuitry you do like this programming for IBM, like this programming for Microsoft, like this programming for Google, and this is for Amazon. This is too complex, correct? Every machine you have to program differently. So that is the challenge. So different hardwares, different software, and if you want to build applications that can port and run across, it's a complex. So this is the opportunity. Any problem is the opportunity for researchers. So it is also opportunity for us also. So let me briefly share 2. One, this QFAS, this serverless computing, function as service is very popular in the cloud. So we want to apply the same thing so that we can build application quickly and deploy. Then this is for those who not able to get access to the quantum, but you still have a desire to do some innovation, you can use this iQuantum simulator. So each of those, let me explain briefly. So this is the high level architecture. So let's say here we got this QFAS survey platform. So made up of function templates. You build an application. So having multiple functions. Some functions are our classical function which is already there, and one of the function is quantum. Because the entire application, one may be doing too many calculations, too many loop of say 1 million loops, and that one we quantumized. And that one when you submit to the execution layer, so looks into what type of application is it. Is it a classical, run on a classical computer? Is it GPU, run on a GPU? Is it a quantum, run on a quantum hardware if you have one? You don't have, then you can run it on an emulator. You can put that emulator, but of course emulator will take more time. So, this is the system we built, and obvious benefits are, so simplifying application development, then of course no vendor lock-in, then have a mix of quantum and classical together. So, those are the benefits. Then what about backend selection? Let us say somehow you managed to have access to IBM Quantum, correct? Either you got the money or you made a deal with IBM CEO and he gives you access. So, this is the, if you get IBM network, they have around 20 quantum computer located in different places, they have different names, and then which is the best for my task. So, now for example, so I got, let us say some access to these 5 of these quantum computer, and these are the number of qubits. The biggest quantum computer today has 127 qubits, and of course smaller like this 7. Then what about their performance? How do they measure? Our systems, our laptops, Yoga's laptop is measured performance as a MIPS, million instructions per second, MIPS rating, correct? So, MIPS rating. But in the cloud we don't have MIPS, we have something else, that is called circuit layer operations per second, CLOPS, circuit layer operation per second. Now, given these qubits and this CLOPS performance, let us say I want to run this algorithm, this Joseja's algorithm, then which is the best one? Backend selection. So, based on this our formula, precision score and speed score, whether I value a precision or a speed, because these are noisy hardware, correct? So, if I value a speed, then I better ready to reduce that my precision, one of that. Anyway, based on this, for example, for this we found this one better, even though this is only 27 qubits, but whereas the CLOPS is very high. CLOPS rating is better. So, that is suitable for other one, this one. So, this is that backend selection algorithm. This is the algorithm that we have got. If you do not like it, do not worry, you can put your own. This QFAS is open source software, you can take it, remove this existing one and put new one and compare to ours. Then if it happens to be better, you can publish paper in a better place than where we publish, correct? So, that is one. Then if you run it,
quick time check maybe.
Yeah, okay. So, this is one for factorization. So, this I just want to show you when you run a real quantum machine 200 seconds, and this is the emulator taking more time. Okay. So, then of course, this coming to iQuantum simulator, maybe just briefly. So, those who know CloudSim, so this is CloudSim, has quantum features. What are those? Simple. So, we have got this QPU, quantum processing unit, just like the real world you can define. So, IBM says in 2030 they will have a 1000 qubits quantum computer. You can simulate today, say QP with 1000 qubits. Don't have to wait for 5 years, do it now. Then coming to this task, just like this quantum circuitry, you can define those number of qubits and various gates at arrangement. So, given these two, you can do a research. What is the best way of doing? So, you got 2000 qubits quantum computer, but your task has got 2000 qubits. What do? You can't run it. So, what is the solution? Circuit cutting. So, you find out some circuit cutting, cut those into multiple pieces, then map it to those hardware. So, such research you can do, mapping algorithm, scaling algorithm and so on. Okay. So, that is briefly maybe just, so is a simple example of quantum tasks, another quantum task, how to map this quantum task to this hardware. So, again based on circuitry and based on the topology you can learn. So, here is some simple example of expressing that. So, this is a quantum task with parameter, then quantum data center, the property is defined, then you run the simulation. After running you get lots of results, draw graphs and write papers. Okay. So, you read this simulator yourself. So, I will skip this part, and just to conclude, there are several computing paradigms of Prometheus vision of how to make computer easy. Cloud is the one which made reality. We talked about that, and Anika discussed about better software engineering, then latest application like deep learning, machine learning, and of course natural language processing. So, quantum is rapidly emerging. So, it's a huge opportunity, but there are lots of advances necessary, especially programmability. So, that the circuit programming is too low level. Correct. We need to invent some better languages, better approaches to express. Then the education management is another big task. Actually quite complex. Seems like I have shown it very simple, but if you go deeper, the devil lies in the details. It's very complex. Then of course coming to LLM, maybe this is the last one. So, LLM can also be used. So, this is LLM based resource management. So, for example, let's say you got application like this. a e-commerce application with catalog, cart, and users, payment management, order management. And when you deploy under the latest Kubernetes-based environment, it will look like this. Now, so based on number of load on this, I want to decide how much resource I need to allocate to different pods. Of course, I can do this using the classical one, or I can do using this LLM. In LLM case, this is a standard system. So this is regularly monitor what is going on in the system. Then this is my human expert that I have written, describe that application, what quality service I want, how it should be done. Just a one-page description, high level. So that and this input to the LLM. In your case, we use this Chinese Quen. So input, initially it says no change. Then as things going, so current state and previous state, if there is a loss, you will say, okay, increase, this much resource to this part, or if the performance is very better, no need, then decrease. So this increase, decrease, all that comes, and then you give it to this. And then of course we saw the performance evaluation with this request generation from Alibaba data set. Then request generator through this low cost, run that LLM on this GPU, then other on our CPU. This is the result. Deep learning with less training, so it process these many requests per second, and whereas this LLM did much better. Programming easy, as I told you. I'm sure person like Yogesh would just write this, just wake up in the morning with fresh mind, write the script and feed it to LLM. You have afternoon paper. Yeah, but of course the script has to be pakka, perfect. So, okay, you want to learn more in the cloud. So this is one book. So this is $100. And then of course this is too costly for India. So just RS 600 rupees. So very affordable. It's $10, no less than $10, correct? Depends on exchange rate. So then the same thing for Chinese is just a $3 equivalent. So that is Chinese, and we have got the latest version. And also this book is under print, under Hindi and Marathi, maybe in Kannada soon. So this is quantum computing book as well. So with that, let me stop here. Thank you.
All right, the floor is open for questions. So maybe on this quantum thing, right? So where do you see the role, how can some of the earlier cloud work that's happened, right? How can that be the fastest one part of it, right? But you see other kinds of opportunities that are coming up, especially with respect to, this is going to go more the way of the HPC centers, right? Where you have a few dozens of these available over there, or is it going to be more sitting at your desk, like GPUs are sitting and so on, right? So how do you see that evolution happening? And how can cloud kind of, cloud edge kind of paradigms be helped with that?
Yeah. So first, of course, most of the architectures of quantum hardware, so they are designed to operate under ultra cooled environment. Now, if you want to put them in an edge, you need something room temperature operating, temperature type of system. So there are companies, for example, in Australia, they have got diamond-based quantum computing. They are calling. I don't know whether they use diamond, but it is they call diamond-based quantum computing. What they're saying is we are going to create those processors so that can operate on room temperature also. So therefore, you can deploy at the edge. So for example, smart manufacturing or driverless vehicles. So which require real-time decision in the same place. So if that really happens, then certainly we will have quantums at the edge level. Quantums are already in the cloud already. Quantum intermediate. So that is one thing that will happen. The next, in terms of programmability, it's very, very primitive. So today, programming quantum computers very much like programming computers in 1950-60, where people used to do punch card programming. Even I have not seen how punch card is programmed, but only heard that we punch and then give it to the computer center, come back tomorrow morning. So if you are lucky, no errors, you get the answer. Otherwise, they will say punch again. Correct? So it is very primitive today. So therefore, we need to advance a lot in this transpilers, the compiler, the OS to manage it. Even today, so even the IBM one, so even though, for example, they have got 127 qubit quantum computer, and I have one task which is only 5 qubits, and I somehow submit to it, then what about other? No, only one person can run at a time. So we need to have that maybe partitioning just like we got in our system OS, round robin or time sharing. So that is another area to explore. Then can it be done? How do we do it? If hardware is not providing us a better property, it will be a problem. Then the fidelity aware, so this way we can create a answer that are precise. So this is okay in kind of high level simulation, but if you are applying some financial application, not okay, correct? So 1 0, 1 0, like if you have got let's say $1 trillion money, so that digit, the first one is important. Somebody makes it 0, it becomes 0 money instead of 1 trillion. So therefore that requires a high precision. So whether hardware provides that precision or software provides, and then you have to look at programmability. So these all are open challenges. Okay, this is in brief. So if you want to explore, I'm sure this is a great opportunity for PhD and researchers to explore to start with. Yeah.
What do you expect is the timeline in terms of this quantum computing? Like today, of course, FAS is basically like a wrapper for a code that somebody has written or you have taken help from. But suppose many people want to program. So let's say we started the clouds with IAS, then PAS and so on. So from that perspective, what would the timeline for quantum computing be in terms of when it becomes ease of programming happens and people would start building and translating their algorithms and then execute? What would that timeline
so
be?
more in terms of programmability?
Programmability and also of course affordability.
Yes.
Like, I mean, maybe I have lots of friends today and then I'm able to do something.
Yeah. So one is programmability, other can be this what we call problem solving environments. So perhaps problem solving environments which are much more higher than programmability. So maybe there can be PSC's program solving environment for at least for different domains, make it more easier. Then from there we can transform into whatever low level. So that is another way of going, simplifying to begin with. Yeah. So these all are other invention need to come, advancement. But right now, who are programming this quantum computer? All those people with PhD degree and maybe more research people. So, but if you want to bring the benefit to the masses, we need to high level. I'm sure it will come up. So if this hardware becomes affordable, then also can operate in a room temperature, then you will soon see, just like we have got GPU. GPUs actually has been around for many years, right? Last 30 years we are hearing GPU, but now they have become part of mobile phone. It took 30 years. Now similarly for these QPUs, so right now they are not ready for mobile, but as we move forward, so you will see maybe in 20-25 years time, so GPUs becoming part of mobile phone. I don't know whether it will be part of my mobile phone, but at least some of these our younger people may have one, correct? I may not want to use mobile phone at that time after 25 years, but however, so these are, and the next we are now talking about home robots. Becoming seems like very common. In fact, this is real. I haven't seen this in US, but in China you go and stay in the hotel. So you say, send me some food or some plate. Some robot will come. And it is also very smart. It's coming, then you just go and keep barking like this. It is actually just like humans. It is just bypassing and going. Yeah. So you see these robots really they become very smart. Then they will become robot wife, robot husband. And that robot wife and husband has to be very smart, understand your emotion real time, and serve you properly. Correct? People are saying that you can have a robot wife, you can have a robot husband. Correct? You heard about? Yeah, you can buy a robot wife if you like. Yeah, she will serve you better maybe. Anyway, so they have to serve with good emotion and real time decision. So possibly requires quantum processor and these things. So it is a very different world. But however, as I can say, I'm sure it will come. So it's a matter of time, whether it is 25 years or 20 years, 10 years, only that cost affordability and the temperature and the reliability. Then the application. Applications are there. We can at least for those class of applications, just like GPU, people thought nobody needs GPU. Now everybody starts on GPU. Country's prestige now depends on GPU. Correct? If you don't have a GPU computer, look like you are outdated, no AI application, nothing works here. Yeah, so GPU are. Correct? So if you are not a friendly, no GPU for you. So like that QPU. Yeah, I think that is why everybody is trying to have national mission on quantum computing. So what is the last part?
How can a particle have two states at the same time?
So the
That in quantum
yeah,
as you told.
yeah. So quantum.
Like how can a particle have two states at the same time?
Oh, okay.
It won't include.
So how can this is like how can Krishna be in so many places at the same time? No, there is a special property of Krishna. Similarly, this quantum mechanics, you know. So the way they designed, at least they are. There are various architectures of this quantum at the hardware level. So people talk about silicon quantum, gate-based quantum, then yeah, like this there are various one. So they are some are creating particles, or so even the particle source you might create multiple particles. It may be emulated, correct? So lots of particle having that computability capability. Yeah. So I am not a hardware expert to exactly tell you, but so this quantum dynamics mechanics, so that has this property to be able to create so many things that can be run in concurrently, simultaneously at the same time. Yeah. So that is the physics people have been doing the research in this area last 40 years. They know better. Yeah. Maybe your quantum physics people can tell you, but there is a property. Yeah, so that is why we say programmability or thinking in quantum is very different compared to our classical. Yeah, so we are used to classical style. So that is where we need all these tools that will help us. We still think in classical way, the tool do their job for us. The difference between hardware and our thinking.
Great, so with that, let's thank Raj for a refreshing talk. As well, thank you.
Refreshing talk, as you have given refreshment to them.
Exactly. I'm sure you're all up and away for this more coffee and some snacks outside. Do join us outside, and we can also have a chat with Raj when you're out there. Thank you.
Thank you very much.
Signing. Thank you. So is the recording happen?
Recording, so I will send.
Send the link. Yeah, you already sent the link. Right?
Yes.
Once you've put it in the, we have a chat channel, right?
Our channel for already, once you completed it, sir, already recorded.
Okay.
Available.
Send me a link to that channel.
Okay.
You have other talks also recorded in the channel?
One or two only. Sir.
Okay. Just send it over. That'd be nice.
Okay.
Thank you.